All right, and the last type of graph that we're going to look at is a bar chart. The bar chart displays your categorical variables as equally wide bars. So each height of the bar is proportional to the outcome. So again, that idea of proportional, if you want it to represent 20%, then make sure that it looks like 20% compared to the other bars within your graph. So for comparing and contrasting the graph, you kind of want to talk about what similarities you see and what differences you see. So in this case, I see that for SUVs, Asia and the USA have the same amount of, or same percentage. So Asia and USA have the same percentage of SUVs. For the differences, I might talk about how sedans overall are way greater than any other car. And there's thousands of things that you can say about this graph. So sedans are greater than any other car. There's a whole bunch of things that you could say. You could compare how hybrids are not as popular amongst Asia, Europe, and the USA. You could talk about how, well, trucks are obviously more prevalent in the USA than they are going to be in Europe. So there's a bunch of different things that you can say to compare. Compare means make a similarity. Contrast means make a difference. Okay, so if you surveyed 300 people, roughly how many people do you think would choose a sedan in Europe? So Europe identified is, with my key, is the red one. So I go to find the sedans. That's the highest ones here in the middle. And I'm going to kind of just draw like a rough estimate of where I think that that red one is hitting. So if I'm going to make an estimate, I'm going to say maybe that's 18%. So if this is 18%, and I want to find how many people, or 18% of 300 people, then I'm going to take 0.18 and I'm going to multiply it by 300, and that's going to give me the number of people that chose sedans in Europe, which is 54 people. Again, watch your rounding. You always round down to the nearest whole number for people. So 54 people. Trying to think of what else I wanted to say about this. I don't really like the scaling of this graph because it's just really wide, especially like if you have these graphs that are closer together. Like, is this really 18% or is this 18.2%? Is it 18.3%? And then am I excluding someone in my 54 count for question number 2? So the scaling is important to make sure it's a readable graph that you can actually identify the data that's on there. Okay, and we are going to be going through in a Nearpod your favorite type of ice cream listed out. But if you're not in class and you want to review your notes, then let's just say that 6 people chose chocolate, 10 people chose vanilla, 12 people chose cookie dough, and 13 people chose mint chocolate chip. So then what I'm going to do is I'm going to add up and find the total of all the people. So this right here is the distribution. So I've got 6 people liking chocolate chip, 10 people liking vanilla, 12 people liking cookie dough, and 13 people liking mint chocolate chip. So that's going to be 23 plus 6 is 29. 29 plus 12 is going to be 39, 31. So 41. That's not right. Oh man, math. All right, 41. So the total is 41. Okay, when I make a bar chart, I want you can either do a frequency one, so you can do these categories where you count up to 6, but statistics is way stronger when you talk about percentages, because then you're seeing it as 40, you're not just looking at like small numbers, you're looking at a percentage of a population or of a sample that you've gathered. So I'm going to suggest that you write percentages always on the left-hand side. Now, again, frequency is the count. We might refer to relative frequency as the percent. So if you see relative frequency, that means that you're looking for the percent. If you say frequency, that means I'm looking for the count. And what I mean by count is I would literally have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the left-hand side. Okay, so in this case, when you make your graph, I'm going to go up by 10%. Your graph doesn't have to be exactly like my graph. It can be a little bit different. And I'm just going to go up to, I think 60% should be good, maybe 70%. I can go all the way up to 100 as well. And I'm going to calculate the percents of every single graph or every single outcome. So 6 out of 41 is 14.6%. So 14.6%. And when I make my graph on the bottom, so I've got the label of frequency, that's important. And then I also want to label ice cream flavors because that's what I'm talking about on the bottom. And what you're going to want to do is you're going to either have a key that tells me what each of them are, or you can just go ahead and write out all of them because it's really not that long to write out all these categories that you have. And you can write horribly like I do. So mint chocolate, that says mint chocolate chip if you didn't know. All right, so 14.6 like chocolate. I'm going to draw a bar up to 14.6. Go on to vanilla. 10 divided by 41 is 24. So 10 over 41 is 24.3%. Again, 23.3%. Because these are categories, the bars are separated. Now I could make my bars split by females versus males. So if 3 females and 3 males like chocolate, then I could also represent colors and go beyond my graph, and I could have something like this. The categories themselves are chocolate, vanilla, but within those categories, I can break up by similar characteristics of my graph. So I'm going to take that away for now, but I can have categories like female or male within a category. All right, so cookie dough, if we take 12 over 41, that's going to give us 29%. Okay. And then 13 over 41, because mint chocolate chip is my favorite, so obviously everyone else likes it as well because it's delicious. Sorry if you don't agree. Okay, 31.7%, so that's going to be my largest. Not very significant. I don't see really big differences. I can even say that, that chocolate was the least favorite, mint chocolate chip was the most favorite, but overall, it was a pretty even distribution. So that's how you're making your bar charts. Big thing is the bars are separate, which we're going to talk about on this next slide. So you've seen bars like this before throughout your whole life. This is a graph that goes with categorical data. And that's because you have categories down at the bottom. You're going to have percentages on both sides of the left-hand thing. You can have frequency and you can also have that relative frequency that I talked about. And that is okay for both types of graphs. But this is categorical data. Well, however, this is intervals. So you have intervals of numbers. That's called a histogram because there's a range of numbers that can fall within there. So think about like height. There can be, obviously this doesn't make sense. So maybe let's talk about, trying to think real quick, the number of chip bags that you have. You have 10 to 20, 30 Dorito bags. I don't know. I'm just trying to think. You can have, or chips, the number of Doritos you can have 10.5 chips because one of them is broken. I can't think of a better example right now, but I'm sorry. But this is an interval, which is not a histograph, but a histogram. So categorical, the bars are separated. Histograms, the bars are going to be touching. All right, good luck.